The last thing we're going to do this week is look at some programming we could do to sort of develop our intuition about multivariate statistics and develop some skills that can be helpful along the way. So as the name suggests, univariate data involves just one variable, while bivariate data involves two variables, and multivariate data involves two or more. And so we're going to look at some data that's going to be a good example of how we can think about these different ideas based on some data that was collected during a project David and I worked on together. This is called a hybrid forecasting competition. And so this is based on some data, raw data that was now made public just over the last several weeks. The link is here in the slides, but the data that we're looking at is going to be a substantially modified and cleaned up version of this. And so once again, I'm going to load it up the same way I have before with different data sets. So the variables in this data are user ID, then a math score variable, and this is a sum score of several mathematical reasoning scales, style score variable, which is a sum score of two self-report scales involving open-mindedness and effortful reasoning, and then a PK score, which is a score on our political knowledge quiz. And then there are two experimental conditions, one which has an A, B, and C experimental condition, and another which is whether the participant was a member of a team or worked independently. Don't worry about these too much for now. We may use them later in the semester, but not during this video. So the first thing we might want to do, and this is again more just basic statistical practice, is to look at the descriptive statistics of several of our variables. And so there's a convenient function in the psych package that can help us do this called describe. And this produces detailed descriptive statistics for continuous variables. So here I'm going to load up the psych package, and then I'm going to subset the data to just look at the math score, style score, and PK score. And I'm going to ask for the descriptive statistics on those variables. And so you see, if I do that, I get lots and lots of neat descriptive statistics, mean, standard deviation, median, there's a trimmed mean, minimum, maximum, range, skew, kurtosis. So I would go ahead and look at the help page if you want a little bit more, but most of this should be fairly familiar. And this is a good starting point for describing what's in the data. So the next thing we can possibly do is get a sort of visual sense of what our data looks like. And so to visualize univariate data, which just means a single variable, we can use ggplot to produce histograms or density plots. And these do essentially the same thing. They're just a way of visualizing the distribution of the data. So if we want a histogram, we only need one element, the x-axis, because remember the y-axis is just a representation of how dense the data is at that point. Here we call geom histogram, and I'm specifying bin width equals 1. So that means each column represents a width of 1. So right around 10, this would be all values between 10 and 11. And so this is a way of visualizing the distribution of the data. We can see it's pretty left skewed here, peaks here on the higher end. And the y-axis is the count of observations within each bin. And so a density plot is just an alternative way of doing this. This sort of gives us a nice curve that's a representation of our data in a very similar way. We can see that the histogram and density plots look very similar, and they give us sort of the same sense of the data. Another thing we can do is look at bivariate associations between different variables. And we've seen several ways to do this already. So for example, one way to do it is to look at correlations. So here I'm generating a correlation matrix of these three variables. So we're looking at math score again, style score, and PK score. And these are the correlations between the variables. And we can also visualize bivariate associations with scatter plots, which like I said, we've seen before. This is in one of the other videos that we looked at. And we're doing it in ggplot here, again, with the x-axis being math score, the y-axis being style score, as an example. And then we're using geom point The one piece that's new here is that we can add a regression line by adding the genome smooth with method equals lm for a linear model or regression. And that produces this line. That's the only difference here. So one new thing that's a convenient way of combining several union bivariate descriptive summary or visual summaries is what's called a scatter plot matrix. So a scatter plot matrix is a symmetrical matrix of figures. Along the diagonal is some sort of univariate representation of each variable, so some kind of plot perhaps of like a histogram or a density plot. And then on either side of the diagonal is some representation of their bivariate association. So we're going to use the ggpairs function from the ggally package, which builds on ggplot. And so the defaults for ggpairs, they put density plots along the diagonal, they put scatter plots below the diagonal, and then they just put numerical correlations above. And there are other options for what you can use. Take a look at the help page for other options. But this is a really nice way of looking at the relationships between more than one variable at a time. So here what we see, we have the density plot for each variable along the diagonal. So we just get like a nice little snapshot of their distributions. Then below the diagonal, we see the scatter plots. So we get the relationship between each variable. So here, this plot here would be the scatter plot between mass score and style score. Then at the bottom between mass score and PK score. And then here we get PK score and style score. And then above the diagonal, we get the correlations between each variable. So we get a lot of information from just a very sort of small plot here. Just looking right at us in the face. We get pretty much all we can want about the two-way relationships between each variable as well as the distributions of each variable. So this is a really useful tool to have in your toolkit. So everything we've done so far either looks at univariate descriptions or bivariate associations. What multivariate statistics is doing is taking things beyond these techniques by allowing us to assess more variables simultaneously. And so we can sort of start to see this by using 3D plots. And we can use 3D plots to look at the associations between three variables at once, or the joint densities between two variables at once. And in particular, this idea of a joint density is something that's going to come up quite a bit throughout the semester when we talk about the multivariate normal distribution and things like that. But that's just a sort of preview for what's to come. For now, we can just look at some empirical data and get a feel for what 3D plots can do, which are also good tools to have in your toolkit. So we can't visualize beyond three-way scatter plots or two-way densities just because we can't visualize beyond 3 dimensions. But these plots can give us a feel for what multivariate statistics are doing. Unfortunately, ggplot doesn't have great support for 3D plots yet, but there's another package called Plotly, which does. And Plotly actually seems to be borderline some design for commercial use, but it's free and it has some really neat functionality. So let's take a look. So we're going to start by making a 3D scatter plot. So I'm going to load up Plotly, and then I'm going to generate a figure with this plot underscore LY. And so first I specify the data, then the x-axis, the y-axis, and the z-axis. So remember, this is 3 dimensions, so we have 3 different axes. Then this marker argument here at the bottom just specifies the point size. So once I do this, I can call the figure that I've created by just running this object, which is the figure. And so unlike ggplot, we don't get a representation of the plot directly in the plot pane or the viewer pane because R isn't set up to support 3D graphics or interactive 3D graphics in this way. So what we do is we pop it out into a new browser window. So we can click this little button here, which says show in new window. And this is going to give us our plot in a web browser window. So we do that and we get this interactive tool where we can play with the plots. And so let's actually take a look at what this is going to look like. So here I'm going to switch over. So this is the plot that I produced. And so you can see I can interact with it in lots of cool different ways. I can look at where different points are by scrolling over them. I can also move the plot around. So if I click and drag, I can look at it from lots of different angles because 3D plots, you don't necessarily get the best representation of them from a single angle. Sometimes you want to look from more than one angle. And so you can really move it around and do different things with it. There are different tools that allow you to zoom or pan or rotate. So this is rotating in a different way. So I encourage you to sort of play around with this when you play around with your Plotly plots. And then once you get an angle that you like, you can download it as a PNG. And there are other ways to download it as other file types, but this is for the interactive tool, you get it as a PNG. So that's accessing your Plotly plot. And then, so then once you download it, you can import it into some kind of file that you want. And so this is a 3D scatter plot. And so this is the sort of three-dimensional point where each of these scales meet. And so it gives you a sense of the three-dimensional association. And obviously the relationships between these scales aren't very informative. So this kind of looks just like a blob, but you might see some interesting shapes emerge when you look at 3D scatter plots, similar to how you might with 2D scatter plots. And so here we see it from a different angle. So you can see here, I have PK score and math score along the bottom, these sort of horizontal axes, and then style score along the vertical axis. And here I've rotated it around. So now we have math and style on the bottom and PK vertical. So we're just getting a different view of our scatter plot. So Plotly also allows us to make 3D density plots, which are something also fairly new. And this allows us to visualize the joint distribution of two variables at the same time. So we need an extra step to do this. We also need this KDE2D function from the mass package, and this is two-dimensional kernel density estimation. And so what this is just a fancy way of creating a matrix where the rows are the range of possible values for one variable and the columns are the range of possible values for another variable. And the cells where they intersect are some representation of their joint densities. So to do this, we enter the two variables we want to summarize into this KDE2D function, and we create a new object. And so this becomes a list, actually, not a matrix. And the reason is because a matrix doesn't necessarily have row or column values that are unique. So what you see here is this created 25 values for X, which represents PK score. So this is a range of 25 possible values for X. And then Y is a range of 25 possible values for style score. And then Z is a matrix in which the joint densities are estimated. So it's a 25 by 25 matrix where the rows are associated with these X values and the columns are associated with these Y values. And so once we have this, we can plot it. And so we use this object to plot our data. So X is the X variable from the KD object, Y is the Y variable from the KD object, and then Z is the Z matrix. So these are the densities. So X, again, is the first variable, which is PK score, Y is style score, and Z is their joint density. So we're going to use this pipe operator and use add surface, and this tells it that we want a surface plot, which is how we visualize a joint density. And then to sort of customize the axes, you can use this layout function. And note that inside this layout function, everything's got to be sort of lists. I'm not sure exactly what the programming reason is for this. So it's a little bit tedious, but you just got to keep nesting lists inside of lists. And so this is how you can name your axes. Here I'm naming the x-axis PK score, the y-axis style score, and the z-axis density. And then we can access our figure again, like we did before. And we get this kind of neat 3D density plot. And once again, you can rotate this around and look at it from different angles. And one sort of cool angle that you can do with a density plot is if you look at it top down, it looks just like a heat map. And so where the denser portions are the lighter colors and the less dense portions are the darker colors.